Welcome, everybody, to a special edition of UFO Man Live. My name is Tim Dust, or UFO Man. You can call me either one. I have a special guest host this week. His name is Anthony Esemplare or Esemplare. Doesn't matter how you call him, he says, but it's Esemplare. Welcome, Anthony.
Thank you. Thank you. Pleasure to be here.
Also, we have another panelist by the name of Darcy Weir. He is a film director, correct?
Yeah, I'm a filmmaker. I've made over 13 feature-length documentary films at this point, and a lot of the research I've been doing recently focuses on UAP stories involving space. So, either in our solar system or, in our atmosphere.
Gotcha. Our very special guest this afternoon is an Israeli theoretical astrophysicist who is currently attached to Harvard University, Dr. Avi Loeb. Please welcome Avi Loeb to the panel.
Thanks for having me. You should have introduced me as a farm boy rather than the titles you used, but it's okay.
Okay, a farm boy, guys. He's a farm boy, but still one of the most prominent scientists studying astrophysics on the planet and in the United States. So if you have questions in the chat, feel free to pose them and we will get to them when we can. Anthony, yes, I know you're biting at the bit to come out with your first question, so go ahead.
Professor, thank you for being here. It's a pleasure to be on the panel with you today. And I just wanted to ask, some theories go beyond saying that this could be alien origin, speaking of Oumuamua. You kind enough to tell us what you are saying, not saying, to better help everyone understand about Oumuamua?
Right. So that was the first object from outside the solar system that was reported. And it was discovered by a telescope in Hawaii called Pan-STARRS that was surveying for near-Earth objects. So this was a near-Earth object. It flagged it, but then the astronomers realized it's moving really fast, too fast to be bound to the sun. And so they flagged it as the first interstellar object that came from interstellar space, not bound to the sun. Everything we've seen before, all the rocks, the planets, are bound to the sun. And so the assumption was it must be a rock ejected from another planetary system. That's the natural thing to expect. But as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. It was roughly the size of a football field. And the best fit to the variation of light as it was tumbling was that of a flat object. There is a scientific paper that claims at the 90% confidence that it must have been flat. So just think about a flat object changing the amount of area that it shows us by a factor of 10 as it's spinning, as it's tumbling, sort of like a piece of paper. That was the first clue that it's quite unusual. We don't see objects like that within the solar system. But then the object exhibited an excess push away from the sun. It wasn't moving just as a result of the sun's gravitational influence. And so the question is, what was pushing it? And the obvious candidate would have been evaporation, like the rocket effect. We see comets running away from the sun faster than you expect because the gas that is evaporated from their surface, basically it's water ice on the surface that gets evaporated by the sunlight. It's pushing it, the comets, the other way. And so people were looking for cometary tail, but there was no tail, no cometary tail whatsoever. At the very high confidence, the Spitzer Space Telescope looked very deeply and put very tight limits on carbon-based molecules or dust around it. So the question was, what is pushing it? At which point, there were too many peculiar things, some of which I don't have time to discuss. Also, where it came from and what frame of reference it started from. And the bottom line was that so many peculiar things that I thought the most natural way to give it that push would be for it to reflect sunlight. And for that, it had to be very thin. And nature doesn't make flat, thin objects. And so I suggested it might be artificial, sort of like a sail being pushed by sunlight. And there was a lot of pushback against this idea. But 3 years later, there was another object discovered by the same telescope that exhibited an excess push away from the sun by reflecting sunlight without a cometary tail. And within a few weeks later, the astronomers realized, oh, this one actually came from the Earth. It was a rocket booster that was launched by NASA in 1966, floating in space, and we just saw it again. And it was made of stainless steel, and therefore there was no cometary tail because it didn't get evaporated by the sunlight. And but nevertheless, it had thin walls, and that's why it was pushed. So here is an object that we know is artificial because we made it. The question is, who made Oumuamua? And of course, my colleagues refused to discuss it. And you ask yourself, okay, so what was the explanation for the weird properties? For example, the push of the object, or the fact that it was flat, or how did they explain those facts? And the suggestion was always of something that we've never seen before. It was, maybe it's a hydrogen iceberg, a chunk of frozen hydrogen that gets evaporated, but we can't see it because hydrogen is transparent when it's in gas phase. And the problem with that is that it won't last the journey in interstellar space. It gets evaporated very quickly. And the authors of that proposal agreed with our paper. I mean, that there is no way to escape from that. So then another group said, well, maybe it's a nitrogen iceberg, a chunk of frozen nitrogen chipped off the surface of a planet like Pluto. And there the problem is the mass budget. There is just not enough solid nitrogen on the surfaces of Pluto-like planets to account for a large enough population of chips the size of a football field. And by the way, we've never seen anything like it. Finally, there was a suggestion, maybe it's a cloud of dust particles that are loosely bound, 100 times less dense than air. Just think about it. It's a cloud 100 times less dense than air. And then when it comes close to the sun, the problem is, I mean, it could get pushed, but it will also be torn apart because it will be heated by hundreds of degrees and will not survive that journey. So all of these proposals had problems. And I say, even forgetting about the challenges that they face, if you have to think about something we've never seen before, think also about the possibility that it's artificial. And then, of course, there were 2 other objects that we discovered with my students that were meteors from interstellar space. And they also looked very weird in the sense that their material strength was tougher than iron, tougher than all the space rocks we had seen. And they were discovered in 2014 and in March 2017. So before Oumuamua, roughly a meter in size, each of them. And they were observed by burning up in the Earth's atmosphere. So what I say is the first 3 interstellar objects appear to be unusual. And maybe we're getting a message here that we shouldn't assume that they are rocks.
Right. Wasn't there recently a discovery of, hold on a second here. Wasn't there recently a discovery of a new object that just came through our solar system that was kind of stretched out, that passed within 1.1 million miles of the Earth, and it was just a few days ago?
Yeah, there was an object elongated, sort of like a football field, but this one was with an axis ratio of 1:3, so it was 3 times longer than it was wide. What I was talking about, and this one was imaged by radar, by the reflection of radio waves, because it passed close enough to Earth for us to do this. Oumuamua was too far for radio imaging. But the point is that Oumuamua was 10 to 1. So just think about the difference between something that is 10 times longer than it is wide projected. It could be very thin, but just like a piece of paper that is not exactly edge on. So 10 to 1 is very different from 3 to 1. You know, a factor of 3 is big. If you want to, for example, bring something through your front door, if it gets through the door is roughly 3 to 1, you know, in X. But suppose it's 10 to 1, you know, it's very different.
Yeah.
Darcy.
Okay, my turn. When you say that the object was interpreted to be possibly flat, why is this an anomalous sort of characteristic for Oumuamua? If it's not an asteroid, if it's not some kind of natural, you know, object that should be floating around in space, what is it about that characteristic that makes you think, okay, this is possibly from a relic? It's a relic from an intergalactic intelligence that's passing through our solar system.
Right, but it was not just the flat nature of the object, but what's unusual about being flat, I mean, as you remember, there was an illustration by an artist that Oumuamua was looking like a cigar in that illustration. Obviously, we didn't have an image. I mean, if we had an image, we could have inferred immediately how it looks like. But this, imagining it as a cigar, 10 to 1 axis ratio, is not really the right way to think about it, because that was in projection. Just imagine a piece of paper which is not exactly edge on. It could look like 10 to 1, but in fact it's extremely thin, but it's not perfectly edge on. So the question is it really a flat object like a piece of paper, or is it like a cigar? In both cases, you can project it as it's tumbling. It would look as if the amount of light reflected from it changes by a factor of 10. And so the fact that it's actually flat makes it very different from this object we just discussed that came close to Earth. If you look at this object that came close to Earth, it was an axis ratio of 1 to 3, but it looked sort of like a football. And if you imagine Oumuamua being an extension of that, it would look like a cigar. But if it's flat, it's something really different. And we don't see such things in the solar system with a ratio of 10 to 1. And it gave me the idea that maybe the reflection of sunlight is actually what is pushing it. Of course, if you have a sail, that is just like paper, or even if you have a cylinder, you know, the way that this object 2020 SO that was discovered in September 2020 that I mentioned, the rocket booster that NASA launched, that was a cylinder, but it was thin, and you know, we don't know how Oumuamua looked like. We didn't have a photograph. I would never write the book Extraterrestrial if we had a photo album of Oumuamua. You know, it would have saved me a lot of effort because a picture, you know, is worth 66,000 words in my case, the number of words in my book.
Okay, so just on the top of that question, you also stated that it was tumbling. So does that mean that it was rotating? Like
no. So a spinning object around an axis is not the same as tumbling. Tumbling is that you don't have rotation around, let's say, the long axis or the short axis. You have some very complicated tumbling motion. And that means, you know, if it's, for example, if it's an artificial object, it means that it's perhaps not in control of its motion, that it's space trash. It's sort of, the way I think of this, it could have been a piece of a bigger object that was torn apart, a surface layer. Recently, I wrote a scientific paper that was just accepted for publication a few days ago, where I suggest maybe it's a piece of a broken Dyson sphere. You know, Freeman Dyson, about 60 years ago, suggested that a very advanced civilization would build sort of a spherical construction around their star so that they can harvest the energy of the star. You know, we just use, even in the context of clean energy, the best we can hope for is to use the energy that is impinging on the surface of the Earth. That's what everyone is talking about politically, trying to harvest the energy of the sun. But a more advanced civilization would surround the sun with material that collects all the energy output from the sun and use it. And that's what Freeman Dyson imagined. And the problem is you cannot build an iron sphere around the sun because there is a very strong force.
Gravitational pull.
The gravitational tide will basically break it apart for any material that we know of. So it makes more sense, and that's what Robert Forward suggested, to make it out of segments that are light sails that are just hovering above the star, where the gravitational force is balanced by the radiation force outwards. So they're basically just hovering like kites above the star, and they cover most of the surface just by overlapping with each other, these many segments. Now think about this. To maintain it would be a huge effort, because every now and then an asteroid would collide with this structure and would pierce it. And I calculated that if it's not maintained for billions of years, it would break apart, and you will end up with broken Dyson sphere pieces floating in interstellar space. Now, they would go to interstellar space because these pieces were hovering above the star. So it means that the force of gravity was not really binding them. They were just very marginally bound. And then once they break up and they get pushed out of the planetary system very easily, they can escape very easily. So another possibility is that Oumuamua was a piece from a broken Dyson sphere. And I suggested it in a new paper that was just accepted for publication.
So just really quickly, guys, in terms of an object like this coming from, possibly a relic intelligent species that's somewhere out there in the stars, how would an object like this survive going through the Oort cloud around our solar system and, the treacherous asteroid belt that surrounds our star?
Yeah. So in fact, in the paper, the original paper that I wrote on the subject in 2018, about a year after the Oumuamua was discovered, we submitted the paper, by the way, and within a few days, 3 days, it was accepted for publication in the Astrophysical Journal Letters, because the reviewer was very intrigued by the idea. It only took a few weeks after that for everyone within the astronomy community to push back and say, we don't want to discuss it. It's an extraordinary claim. But, if you just use your childhood curiosity, it sounds like a fun idea to examine. And that's what we did in the paper. Now, the one calculation we did was how much damage will be inflicted on such an object as it moves through interstellar space and enters the solar system. And the answer is not much. For reasonable numbers of, given that the interstellar medium is so rarefied, there is not much damage from dust or gas particles impinging on the surface. I mean, it will get bruised. Any object moving through interstellar space is bruised, any spacecraft, but it will not destroy it. So altogether, the answer is it can make its way for very reasonable parameters that explain the appearance of Oumuamua.
Okay, I have a question for you. As Oumuamua was traveling through our solar system, did it make any course corrections on its own to indicate that it may have been an artificial object?
So this is an interesting, very interesting question. All we could tell from the data was collected only when it passed close to Earth. And frankly, the astronomers just observed it for a few weeks, and that's pretty much it, because nobody expected it to be anything other than a rock. And when we observe space rocks, we don't pay too much attention to them. Here is another rock, And so there was data collected, but it was quite limited. And when it moved near Earth, the only thing we could notice is this additional force pushing it, which declines inversely with distance squared from the sun. And that is consistent with the sunlight pushing it. So if you assume that the sunlight is pushing it, it has to be very thin, sort of like a sail, or like this object 2020 SO that was the rocket booster we talked about, where you have a cylinder that is made of a very thin surface. So something like that. But we don't have more data to see if it had, for example, an engine far away that was maneuvering it. Two other things I wanted to mention. I just finished a paper with Sean Kirkpatrick, the director of the new office in government, AARO, that is responsible for assembling all data within government about unidentified aerial phenomena, either in air, water, or space. And we bring up something that I already mentioned in my book, Extraterrestrial, which is you can imagine a mothership which releases a lot of probes, small probes that we would never be able to detect because they are small, just like dandelion seeds. And they would just visit planets as this mother spaceship, mother craft, is going through the inner part of the solar system. And the idea here is that these dandelion seeds can be equipped with a parachute, and they can basically slow down in the atmosphere of a planet like the Earth and eventually pursue whatever goals they have. So the fact that Oumuamua, for example, did not exhibit maneuvering capabilities doesn't mean that it didn't release smaller objects that do have the maneuvering capability. And the other point I wanted to bring up is that the journey through interstellar space takes a long time. Even if you move at the speed of light, which is the fastest any object can move, it takes 50,000 years to go from one side of the disk of the Milky Way galaxy to us, to cross the entire Milky Way galaxy. 50,000 years. We were not that interesting 50,000 years ago. We were indistinguishable from nature. And that's at the speed of light. If you allow for travel with chemical rockets, the type of spacecraft we've used so far, it would take 500 million years. So what I'm trying to argue is they didn't have us in mind. Humanity was not that interesting. It was indistinguishable from nature. When the senders sent any probes that might be visiting the solar system. So we tend to think that we are important. We tend to think that we are the center of the universe, that we are the most intelligent species that ever existed. And I say, the universe is telling us something else, that we are not that significant. We came at the end to this cosmic play that started in the Big Bang 13.8 billion years ago. We are not at the center of the stage. And we see planets like the Earth around sun-like stars to be quite common. And so if you're not at the center of the stage and you arrive just at the end of the play is not about you.
Right.
Very good.
I do have a question real quick from the chat room from Mike Johnson. If it's not from our solar system, do you know the trajectory of where it may have come from? And would James Webb be able to see this now?
Okay. That brings me actually to the thing I omitted, which is the special frame of reference that it was at before the solar system collided with it. Turns out that Oumuamua was at rest in the so-called local standard of rest. It was more at rest there than 1 in 500 stars, in the sense that there is this frame of reference that you get to when you average over the motions of stars in the vicinity of the sun. And that is called the local standard of rest. You can think of it as the local parking lot, where, that's the frame of the Milky Way galaxy locally. And Oumuamua was at rest, just like a buoy on the surface of the ocean that is not moving. And the solar system bumped into it, just like a giant ship colliding with a buoy. So it gave it a kick. But Oumuamua was not really coming from any particular star. It was sitting still in the local standard of rest. So in that sense, it's also peculiar, because if it were to come from another planetary system, it should have inherited the motion of the parent star. And we didn't see that. So we can't associate it with any star. Now, at present, Oumuamua is millions of times fainter than it was closer to the sun. when we saw it. So even the Webb telescope cannot detect it. And frankly, we don't know exactly where to look because of uncertainties in the trajectory. So there is no point in obsessing about Oumuamua. It's just like if you had a good date with someone that disappeared into the night, instead of obsessing with that one partner that you had an excellent date with or that was intriguing, we should think about the opportunity to find other partners, other objects like Oumuamua. And there is the Vera Rubin Observatory that will have a survey of the sky starting a year from now. It will cover the southern sky because it's in Chile. Every 4 nights, the entire sky with a camera of 3.2 billion pixels. So that's 1,000 times more pixels than your cell phone camera. Just think about it, covering the entire sky every 4 nights with a camera that has 1,000 times more pixels than your cell phone. And this survey is likely to find many more objects like Oumuamua. So we are thinking within the project that I'm leading, the Galileo project, we designed a space mission that goes to the next Oumuamua. I call it dating the next Oumuamua, and you can think of the Vera Rubin Observatory. That's a dating app, basically allowing us to decide whether to swipe to the left most of the time, or maybe engage with a potential partner that is of interest to us. The other thing I wanted to mention, if we do find such an Oumuamua-like object, we can look at it from 2 directions, one from the Earth and the other from the Webb telescope, because the Webb telescope is at the Lagrange point 2, L2, very far from Earth, about 1,000,000 miles. And if it looks at an object that is passing in our vicinity, it would look at it from a completely different direction. So just like we have 2 eyes that allow us to gauge distances to objects, if you have the Webb telescope and a telescope on Earth, you look at it from 2 different directions, and you can pinpoint in 3 dimensions very precisely the motion of the object. And that would allow us to figure out if it has any propulsion. That was your previous question about Oumuamua had propulsion. We will be able to tell very precisely whether there is propulsion of the next Oumuamua using the Webb telescope and a telescope on Earth.
Right. Anthony. Can't hear you, Anthony.
Sorry about that. Professor, could you list some anomalies of Oumuamua that we might not be aware of at this time?
Yeah, so first, as I mentioned, it was the flat shape based on the variation of light. It was the excess push away from the sun that without a cometary tail. It was the fact that it had an extreme shape because the amount of sunlight changed by a factor of 10 as it was tumbling. It was the fact that it originated from a special frame of reference. And this local standard of rest that only 1 in 500 stars is so much at rest at. And finally, it didn't show any jitter associated with jets, as you find on comets very often. They have regions that evaporate more quickly than other regions, cavities on the surface where there is more ice, for example. And as a result, they have some jitter. There was no jitter associated with Oumuamua. And also the spin, the tumbling period of 8 hours did not change as you would expect from an evaporating comet. So altogether, quite a number of anomalies. But I should say one thing, it's really funny that about half a year ago, a colleague of mine said, I just finished to write a review paper in a very prestigious journal in astrophysics that describes everything we know about the comet Oumuamua. So I wrote back to him and I said, what do you mean the comet Oumuamua? We both know that there was no cometary tail and it cannot be called the comet. And so he said, well, I have this theory that there was a cometary tail when we didn't look at it. And when we looked at it, it disappeared. So I said, well, it's just like going to the zoo and looking at an elephant and saying that the elephant is actually a zebra and it shows its stripes when we look away from it. That makes no sense. So you ask yourself, how is it possible that when someone from the mainstream of astronomy writes a review paper about an object that doesn't look like a comet, he calls the object a comet? That's a contradiction.
Yeah. So
We have to be honest. It's not a matter of whether you believe it's artificial or not. You have to tell the truth. You can't. So the answer is he preferred to call it a comet so that it would sound familiar and nobody would feel any irritation in thinking about it as being anomalous.
Right.
Just calling it this way doesn't make it this way.
yeah,
Right.
I have a question for you in regards to sort of debunker scientists in your field, right? Debunker scientists believe that the immediate answer to closing down this argument that Oumuamua is from an intelligent, origin rather than a comet or an asteroid or something like that. They believe that the answer lies in the fact that everything is impinging on a physics that's Einsteinian or Newtonian. And I don't know if you're familiar with Eric Weinstein.
I know him extremely well. We were actually on the same panel in Florida in January 2022.
Fantastic. So I think, one of the new sort of questions that are coming out in the mainstream scientific community is, and it's challenging to a lot of physicists, like other than yourself and Eric, is are we looking at possible questions of UAP visiting our solar system with the wrong set of physics? Do we need to discover a new set of physics? And, where do you think we need to go to find that new set of physics that will explain, for example, Oumuamua is a anomalous object that we courted with in the past, and we want to court with other sexy anomalous objects coming into our solar system, so to speak. So how are we going to basically, if we find a really anomalous object, prove to the mainstream scientific community, well, there has to be some other physics here, and this is it?
Yeah, so there is a very simple procedure for doing that. Unfortunately, a lot of people want a shortcut. For example, they would look at an object from one site, estimate the distance, and claim that the object is moving extremely fast in the Earth's atmosphere. That's not a good approach. In order to claim new physics, you need to have very robust measurements. For example, in the context of distance, you need to do triangulation from different sites, look at the same object, just like I was talking about before with the Webb telescope and the Earth. When you have multiple sites looking at the same object from different directions, you can triangulate and therefore measure the distance very precisely. Astronomers have been doing it for century. It's called parallax. It's very standard. And you can't just argue for new physics if your data is incomplete. In fact, I would argue the opposite. I would say if your data is incomplete, you can put limits on the distance so that you would not need new physics. That's the first thing to do. But only if you are pressed with your back to the wall, where you have so much data of such high quality that you know precisely the distance, and the object is behaving in ways that cannot be explained by standard physics. For example, it's moving faster than light. Only then you can argue, I see evidence for a deviation from standard physics. But you have to understand, physicists have been looking for new physics for half a century. For example, the Large Hadron Collider involved an investment of $10 billion trying to smash protons at very high energies and looking for signatures of new physics. The only thing we found so far over the past decade or so is old physics, all the news, so to speak, the Higgs boson, but nothing really new. We were hoping maybe you would find evidence for the dark matter, a new particle. Nothing was found. So physicists have been working really hard in laboratories, trying to find traces of new physics without success for decades now. So just claiming with poor measurements of distance that you have new physics in the sky is really not professional. You can't do that. The bar has to be taller. And this is the message I try to convey in the recent paper with Sean Kirkpatrick, that we need to have very good measurements because the physics as we know it has not been violated in any of the careful experiments that were done in laboratories. So in order to discover new physics, the bar is pretty high, and we just need to get good evidence. That's all. So I'm not saying it's not possible. I'm not saying there might not be objects in the sky that reveal new physics. I'm not saying that at all. I'm saying in order for you to recognize that, you really need exceptional data. You can't just rely on eyewitness testimonies that say, I saw something really weird. So here is an example. Suppose you drive on a highway. You see a black car ahead of you, and then it disappears. And then you see a black car behind you, and you say, wow, that's amazing. I saw a car that moved faster than light because it was ahead of me, and now it's behind me. Guess what? If your information is incomplete, it may be a different car. So when people talk about the tic-tac incident and things moving really fast, how do we know it's the same object? If you see it in one frame at one location, in another frame at another location, maybe there was a swarm of objects. Now they tell me, okay, well, these were military personnel. Fine. I mean, they're very reliable. I believe they're eyewitness testimonies, but that's not scientific evidence. You know that when there is a car accident and you ask people that were involved, each of them would give you a different report, sometimes conflicting. If you ask people that attend a sport event, each of them would describe the same sport event differently. People wish to have reality accommodating with their own beliefs, or they may be fooled by incomplete evidence. The only way to make progress is to use instruments. That's what science is doing. We have to rely on instruments. So if you have a good enough camera, for example, if Moses, in the biblical story of the burning bush, if Moses had an infrared camera that would show that the bush is burning and burning and there is no energy supply, you would say, okay, well, that's a miracle. But we don't have a video recording of that burning bush incident. And that's my point about reports by eyewitnesses. There are lots of people who are put in jail because the legal system believes eyewitness testimonies. And sometimes DNA testing shows otherwise. So we have to rely on physical evidence that is recorded by instruments in order to claim new physics. You can't just say there is new physics because my data is incomplete. And so that's a really important point that many people do not fully understand.
Okay, fair enough. I wanted to quickly ask you, you mentioned earlier Arrow and how you've been brought in to work with that newly set up UAP research office within the government. I think Arrow is important for getting to the bottom of what's going on out there in the cross agencies sort of world of the government and intelligence agencies and defense agencies, and trying to get some more data on UAPs and UFOs, as they used to be called. What is your role going to be going forward with them? Are you going to consult scientifically on historical events that Arrow is trying to deconstruct from the past revolving around UFO or UAP experiences, people that have testimony? Are you going to consult on future events? Like, where do you sort of see yourself fitting in with Arrow and the government studying UFOs publicly?
I'm not associated with this office, and I was not recruited, and I'm not in any official relationship with them. You have to understand, I just wrote a paper with the director of that office, a scientific paper. Okay, so I'm not officially assigned to anything. I'm a scientist leading the Galileo project, which has its own observatory. We are collecting our own data as we speak. We have infrared sensors, we have visual optical light sensor, we have radio passive radar system, we have an audio system going from the infrasound all the way to the ultrasound. So we decided to collect our own data because the sky is not classified. We don't want to rely on eyewitness testimonies, on things from the past when the equipment was not as good as it is today. So, we are basically collecting our own data, and we will analyze it with the state-of-the-art artificial intelligence algorithms that we are developing, and basically try to tell whether, an object is a natural object like a bird, a bug, a thunderstorm, a meteor, or it is human-made, like the balloons that were shut down by the US government. If it says made in China, we don't care about it. I don't really care about human-made objects. I don't care about natural objects that are terrestrial. All I want to know is there anything else? That's all. And in that way, what we are doing in the Galileo project is complementary to government. I'm not doing government service. I'm actually interested in what the government is not interested in. If you see an extraterrestrial piece of equipment, it shouldn't adhere to national borders. It doesn't really matter if it's the US, if it's any country in Europe, China, whatever. That is irrelevant if you come from interstellar space. There was the Orion spacecraft that took an image of the Earth just a few months ago from behind the moon, and you wouldn't be able to tell where the Ukraine-Russia border is. You just saw a blue marble. So when you have a visitor from outer space, it doesn't really care who is looking at it, whether it's American or not. So therefore, the information, the knowledge about extraterrestrial visitors should not be the privilege of the President of the United States. It's not a national security matter. It's knowledge that should be shared by all humans, irrespective of which country they belong to.
But if your information is private,
it's not private. Our information, that's exactly the point. Because it has nothing to do with national security, it will be public. It will be shared by everyone. We will make it open. We will make our analysis transparent. Anyone will be able to look at our data. Just forget about the past practices where data was collected by government. And obviously the government has the best sensors, but these sensors are classified. That's why the government will not release its data. It's not because it wants to keep it secret, the data itself. It's because the sensors used to collect the data are classified, and the government doesn't want adversaries to be aware of the quality of the sensors. That's all. So I'm saying, we bought off-the-shelf instruments that are not classified. You can find them on Amazon. And we put them together. We built an observatory. We have nothing to hide. And the sky is not classified. Therefore, we will make our data open. That's the way science is done. But our work is complementary to the government's work. The day job of government officials is to warn the intelligence agencies against national security risks. And those are the kind of objects that we don't care about if they're human-made. We are not interested. We will be happy to share all the data we have on human-made objects, natural objects. For natural objects, it will be with zoologists. For human-made objects, with Washington, D.C. I don't need this data. I don't want to look at it. I don't care if it's a balloon of one type or another and what is the payload. I just want to figure out if there is anything else that came from extraterrestrial space.
So I spoke with Seth Shostak, who's on the board for your Galileo project, in making this documentary that I'm working on. And, I asked him, SETI is a private organization similar to yours. How if somebody wants to access that data to do their own study of what's coming through these radio telescopes, how do you disseminate that? And he said, well, all of our data is proprietary, so they would never be able to take it from our organization and even look at it on their computer, because they have to have special software and algorithms to actually decipher what we're finding. So that's kind of impossible.
Yeah,
how are you going to make your data non-proprietary and able for the public to you say open, people think of SETI as this very open organization that's also privately funded. It's not government.
The source of the money is not the issue. The question is, what do you do with the data? And we will make it available. Anyone can download it and analyze it, and everyone will know how we did it, because we will publish it in scientific papers. Now, the one thing I wanted to comment is SETI for 70 years was focused on detecting radio signals, because that's the approach pioneered by Frank Drake, who passed away about half a year ago. And back 70 years ago, it made a lot of sense, since we started developing our own radio communication, to look for other radio signals from other civilizations. As of now, it's not clear that this is a good approach. Well, first of all, it's just like waiting for a phone call. Sitting at home and waiting for someone to call you. You need the other side to be active when you are listening. And there is a much better approach that the SETI community did not engage with. And that's the approach that the Galileo project is taking, which is to search your mailbox for any packages that arrive. Because even if the sender is not alive, the packages will accumulate in your mailbox. So physical objects offer a very different method of search, and that was not looked for. And not only that, but I should say I'm really surprised by the response of the SETI community to this other approach. They are very hostile, and perhaps that has to do with claims of non-professionals that they have witnessed UFOs or were abducted and so forth. So there is this whole culture out there that the SETI community does not want to be associated with. Maybe that's the reason. It doesn't really matter. The point is, this is a search method. Looking for objects is a search method that might be far better than looking for radio signals. And I don't care really about the history of this subject. That's completely irrelevant. If there are objects or probes near Earth, we better find them, irrespective of what people said in the past. I don't have any account on social media. I don't care how many likes I have. It's not a popularity contest. I don't care if SETI people have something bad to say about the search for objects. That's irrelevant. If there are objects around the Earth, we will find them. And that's just like what happened to Galileo. He was looking through his telescope, realized maybe the Earth moves around the sun, and people put him in house arrest. They didn't want to listen. But obviously, that didn't change the orbit of the Earth around the sun. There is a physical reality out there.
Sorry to hog the mic there, guys.
No, not at all. Maybe searching for radio waves isn't the way to go. Maybe we should build a telescope that should search for maybe industrial pollution outside the Earth's atmosphere. And I say this because let's say we had a planet way out, and the planet was ice cold, and they wanted to terraform that planet. They could terraform it by putting a thin layer of pollution around the planet, right? And by doing so, we can have a telescope that can search for that industrial pollution. Maybe devising telescopes like that would be a better advancement and better money spent.
Well, you're preaching to the choir, because I wrote a paper back in 2015 making exactly this point. That was the first paper that calculated industrial pollution on a planet. And I wrote also an essay in Scientific American talking about the fact that this may be on purpose in order to warm up the planet. So what you are saying is basically what I said 8 years ago. And maybe someone else read it and said the same thing after reading it, and that's why you are saying it. But actually, I said it in 2015.
So why do you think that we haven't started doing that yet?
Oh, because people ignore this suggestion, just like they ignore the search for objects. you ask yourself, why is that? Why isn't this part of the mainstream of astronomy? Part of it is inertia, that people worked on lifeless objects in the past, so the Nobel laureate Steven Weinberg, in his famous book, The First 3 Minutes, he said, the more the universe appears comprehensible to us, the more pointless it looks. And I say it looks pointless because you focus on lifeless, on dead objects. You focus on elementary particles, you focus on stars, on galaxies. Once we find a partner, another civilization like us, it would give meaning to our life. Just like finding a human partner, it gives meaning to your life. So the universe will stop appearing pointless if we find another intelligent civilization. And moreover, we could learn from them if they are far more intelligent than we are. Cool. Frankly, I don't think we are the pinnacle of creation. Just look at how many resources we're wasting on fighting each other, trying to kill each other. We spend about $2 trillion every year on military budgets worldwide. And I calculated that if you use these $2 trillion a year for space exploration, you can send a CubeSat to every star in the Milky Way galaxy within several decades. Just several decades. Every star, a CubeSat. So if you ask yourself, is it possible that there is a CubeSat close to Earth? That's an object, the size of roughly 10 centimeters on the side. Is there a CubeSat? Well, if there was a civilization that believed in what John Lennon said, imagine all the people living in peace. If you think about a civilization that liked John Lennon theme and decided instead of killing each other to venture into interstellar space, 1 billion years ago, their probe may be here. Just for a few decades, if they focused on that just for a few decades, instead of initiating wars, instead of defending themselves, if they just believed in peace and exploring space, if we did that, we have so much that we could have accomplished.
Agreed.
Okay, I've got a question in regards to history. I know that you did mention you're not very interested in history, and I've spoken with Beatrice Villarreal.
Yes.
Roel.
I corresponded with her by email just a couple of hours ago. Yes.
Yeah, and she's a great scientist. I think she's involved with the Galileo project in some way. And she has a novel sort of approach at looking at past plates that have recorded objects, around outside of our solar system in the star fields and aiming out at other galaxies. When looking at that data, she wants to try and extract from these past historical plate recordings, maybe with the current technology that we have, filtering out what we know should be there now,
right?
With our new analysis of this outside and in looking at the galaxies in the universe. So put that filter in and say, well, this is supposed to be here. This is not supposed to be here. So maybe in even historical plates, we can say there's a lot more Oumuamuas or even other anomalous objects floating around out there, traveling around out there. Is this something that the Galileo project is going to sort of tackle? And I know that one of the problems with this, before you answer, is that, she kind of came up against a wall when she wanted to access those plates because it's in a university repository, and that university is saying to, this PhD, astro scientist that, sorry, that's our data and you're not privy to that. Is there a problem, do you think, with the academic community where they want to hoard data that they've got that's historical and say, that's kind of our copyright? We only want our scientists or undergrads or PhD candidates working on that, not outside scientists?
Well, it depends on the university and it depends on the data. It depends on the rules of the collaboration that collected this data. And some data sets are publicly available. Just to give an example, the Vera Rubin Observatory is funded by the National Science Foundation. The data coming out of it will be available to anyone, okay? Because it's anyone in the US, I should say, because it's paid by taxpayers funding. And so that's an example, but there are sometimes private projects that are funded by either organizations or collaborations or universities, where the people who collect the data want to have a privilege of analyzing it just because they invested a lot of time and money in it. And that's unfortunate. I don't like that, because I think science should be open. Of course, you can milk the data early on for a limited period of time, let's say a year, if you really want to be privileged. But after that, you should let others look at it, because they may find new things, just like Beatrice is seeking. So I'm very much a supporter of what she's doing. The reservation I have is that, a century ago, we didn't have high quality data. And a year from now, the Vera Rubin Observatory will have 3.2 billion pixels of the sky, serving the southern sky every 4 nights. So that would be a huge data set. And I much rather focus on that. And I am focusing on that with my postdocs and students. I'd rather prepare myself to use that data than some old data that lies in the archives from a century ago. I'm always interested in the latest and most advanced things that we have. I like new music more so than music from the 60s. I don't really like the Beatles, even though I mentioned John Lennon. I like everything that is current. And by the way, in the context of that, I also like artificial intelligence systems. I think we should make sure that they don't damage society, of course. But I would be very proud of their accomplishments, even if they replace scientists, if they replace astronauts. If we send autonomous AI astronauts to space, that would offer a great advantage, because they will not wait for guidance from humans, and they could venture into deep space very far away from Earth and pursue our goals. And I would trust them more than human astronauts, because the human body is very vulnerable, in space, and also the human mind might not be sufficiently robust. And just sending AI astronauts makes a lot of sense to me. It was not done yet. And then you can employ AI systems in science. They would replace scientists. They would not have a prejudice. If they see an object like Oumuamua that doesn't look like a comet or an asteroid that we had seen before, the AI system will admit that it's anomalous, will not classify it as a comet, will not adhere to what people said about it in the past. That's irrelevant, because it will not be attached to its ego. And I like that more. So my approach is very similar. If you want to think about me, I said at the beginning that you should think about a farm boy, because I think like a kid. I don't care so much about myself. I just want to learn about the world. I'm wondering about the world. I want to figure it out. I'm not attached to myself. I want to just know what's out there. And, if in the process of learning, we make some mistakes, so be it. But let's just find out without having a prejudice. Apparently, even though it sounds simple to be like a kid, it actually is very rare to find this approach among adults, because adults worry about the way they are perceived. They want to get a lot of likes from the social media, from people that they know. And so they always tailor what they say and how they behave such that it would appeal to people. They don't pay attention necessarily to nature. They pay attention to other people. That's pretty bad, because then, first of all, you don't study things that are uncomfortable. And, just to give you an example, a few years ago, mentioning the idea of a lab leak was like suicide in academia, because everyone was canceling. Any person who said that the virus COVID-19 came from the Wuhan lab. Now, if you open the news over the past week, the head of the FBI is saying that's the most likely origin. Okay, and the Department of Energy is saying that a few days before that. And so you ask yourself, how is it now acceptable? Just a few years ago, it was banned from any discussion, any serious discussion. And now the intelligence agencies are saying it's the most likely thing. So does it have anything to do with reality? I mean, the way we select ideas that we like and ideas that we don't like has nothing to do with the facts. It has to do with a group of people deciding that going in that direction would not satisfy their wishes in one way or another. That's not the way to guide us about reality. Okay? And so my point is, behaving like a kid is not an easy task. You always want to know the answer in advance as an adult. You want to pretend that you are something that other people respect. And that brings you in the wrong direction on occasion. And so I want to believe that I behave as much as possible like a kid, because I don't care what other people say. I just want the evidence to guide us. And the Galileo project is not within the mainstream of science, and it's out of the box for many people, thinking out of the box, just because the box is in the wrong place. That's the way I see it. And common sense is not common. That's what I realized within academia. Common sense is not common. It becomes common once the evidence is beyond a reasonable doubt. So once you collect evidence, and people always quote Carl Sagan, they say, extraordinary claims require extraordinary evidence. And I say, well, if you're not seeking the evidence, you would never find it. And extraordinary evidence requires extraordinary funding. You need to fund the search in order to find anything. And that's what the Galileo project is doing. I got private funding that allows us to search. And there was never a robust scientific program like we have right now.
I have a question for you for you, Darcy. I'm sorry. I want to expound on the idea of the fact that the Project Galileo is fully funded for a project where you are trying to recover an object from the ocean floor near Papua New Guinea. Can you elaborate?
Yeah, so that was an interesting story. Back at the beginning of 2019, I was invited on a radio show to discuss a meteor that fell off the Bering Sea near Kamchatka. And I didn't know much about meteors, so I went online and I found a catalog of meteors that the US government compiled. It was published by the Jet Propulsion Lab in Pasadena, a NASA entity. And I saw 273 objects cataloged starting a decade ago. And so I said to my student, I said, why don't we check, given that Oumuamua had a very high speed and therefore came from outside the solar system, maybe one of these meteors has a high speed and we can tell that it's not bound to the sun. And so we looked into it and we found an object from 2014. And it clearly moved faster than the escape speed from the solar system. So we wrote a paper about it, submitted it for publication, and the reviewer said, no, rejected. We don't believe the US government. They gave us numbers, but without uncertainties. Now, of course, the US government didn't give uncertainties for the same reason that they don't release UAP data. They don't want adversaries to know the quality of the sensors they're using. But given that our paper was rejected, I reached out. I was chair of the board on physics and astronomy of the National Academies at the time, and one of the members was from Los Alamos. So I reached behind the national security fence, and eventually, with the help of a person in the White House, there was a letter written 3 years after that, in March 2022, to NASA from the US Space Command under the Department of Defense, stating explicitly that the precision of the data is such that they can testify that this object came from outside the solar system. This meteor from 2014 is interstellar at the 99.999% confidence. So the Department of Defense came to my defense, and we resubmitted the paper, and it was accepted for publication. It was published a few months ago. At the same time, the government also released data on the fireball, the light that was emitted when the object burned up in the lower atmosphere of the Earth. And that allowed us, my student and I, Amir Siraj, to figure out that the composition of the object was unusual because it was tougher than all the other space rocks in the NASA catalog, 272 of them. So why would the first interstellar object, and by the way, it was 4 years before Oumuamua, this object, roughly a meter in size, burned up in the Earth's atmosphere, but tougher than all the other meteors in the same catalog that came from the solar system. So why would the first interstellar object be of unusual composition? If it's a rock that came from another star, it should have had some properties that are similar to the rocks in our solar system. And this one was at least a few times tougher than iron. And so what we decided at that point is to plan a mission, an expedition, to visit the site of the meteor and scoop the ocean floor for any fragments left over from it near Papua New Guinea. And the amazing thing is that we received, the expedition will cost $1.5 million. And there was a very generous donor that supported the mission. And we have a boat. We have an exceptional team of people who are very experienced at the expedition. The fundamental question is whether we will retrieve anything. I mean, we are using a sled with a magnet and some equipment. You know, my wife keeps asking me, do you think you will find anything? And I say, well, if we don't search, obviously we will never find anything. So we have to search. And just like any scientific project, you know, you can never tell what you will find, but you have to engage in it in order to see. Maybe we will find something, and if we do, we will analyze the composition and be able to say whether it was a rock or some artificial alloy like stainless steel that made a spacecraft that collided with Earth.
Right. Darcy?
Very, very cool. Yeah, you mentioned that the Department of Defense collaborated with you on this. Do you see the Department of Defense possibly collaborating with you further in the future in regards to UAP and what you're doing with the Galileo project? And do you think also that maybe they have some data in their records that they could probably bring public?
I haven't seen any classified data as of yet. There is this saying in Judaism, I'm Jewish, there is this saying that prophecy was given to fools after the destruction of the temple. So I don't want to appear as a fool to, make prophecies about the future. I don't know whether they would partner with us or not. It's up to them. At the moment, we are having our own project, and waiting for the government to declassify data is, sometimes feels like waiting for Godot in the Samuel Beckett's play. You can wait forever and it will never come. So I think we need to take action into our own hands. We can collect data on the sky. There is no need for us to rely on government. We understand why the government is not releasing the data. It's because it's using sensors that it doesn't want adversaries to be aware of. So that's completely understandable. It's not a conspiracy. It's just their interests are national security. It's different from the scientific interests of the Galileo project. So we are doing complementary work. We don't care about anything that is human-made, and we just want to see if there is anything else technological out there. And I don't think we need to wait for them or ask them necessarily to declassify things. It's not their day job. Their day job is to protect the nation, to protect the safety of military personnel. That's their obligation, and you can understand where they're coming from. So why would we ask them to do something against their nature? The government is not a scientific organization. So I have scientists in the Galileo project, and we can do the work.
Do you, when you look at the scientific community, and there's people like yourself, Beatrice, the people that are on the Project Galileo panel, the group. And then you've got guys like Eric Weinstein, taking this seriously. Do you, and historically, I mean, what do you think of people like famous former Harvard professor, Dr. Johnny Mack? What do you think is happening in terms of this UAP subject in the mainstream scientific community? Is it opening up? Is the mainstream community clamming up? Will it always be the same? I don't want you to be a prophet, but what are your thoughts?
Yeah. So first, I would say about Mac, even though he was at Harvard, what we are doing it has nothing to do with what he was doing, because, as I said before, humans are not scientific detectors, and therefore humans should not be used to claim evidence for an extraterrestrial visitation. He was just focusing on humans. So I say what he was doing has nothing to do, no overlap whatsoever with a scientific project like the Galileo project. We are not consulting humans. We are building instruments that will record whatever is out there. Okay? So eyewitness testimonies may be intriguing. They may be motivating. Most recently, there was an interview of Steven Spielberg by Colbert. And it was just a couple of days ago. And Steven Spielberg was talking about UAP as being very exciting, and maybe it indicates new physics and so forth. And I say, this could inspire film directors to have new scripts in Hollywood, but it's not evidence. Everything that he was talking about is not scientific evidence. You can have science fiction, but we need to separate science from fiction. How do you do that? You don't attend to what people say. You just attend to the data and the evidence that you collect. That's what you do. Fiction is in the realm of people. Mac was focusing on people. So he may have been fooled by fiction. That's a very simple conclusion. I say the correct way to make progress in our knowledge about UAP and what they are is to collect data with cameras, with sensors. The government may have that data. That's why the discussion is opening up. There might be much more data now than used to be in the past, because the government is employing sensors with much better quality than we had decades ago. What that means is that we shouldn't go back to historical evidence, because the sensors back then were really not very good. We should just try to collect better data in the future. So instead of trying to dig into archives, we should just look forward. That's my general recommendation. Always look forward because now we have better sensors. Now we can collect the data ourselves, because science is at the point where we can detect interstellar objects. That was possible only over the past decade. You might ask, why are the first 4 interstellar objects discussed only now? Well, the reason is only now we have the sensors that could detect them. The Survey Telescope Pan-STARRS did not exist more than a decade ago. And the government sensors that discovered the meteors that I mentioned from interstellar space did not exist before. So we now have those capabilities of detecting interstellar objects. We have the capability of seeing what UAP are all about. So let's go ahead and analyze data from new observations, new instruments, rather than obsess with the past. That's my point. A kid is being told stories over and over again by adults. And a kid says, the hell with what the adults are saying. I don't want to listen to that, because they keep telling me stories. I want to find out myself. That's the approach of a kid. And I think it's much healthier, especially given that we have much better instruments now. We should march forward rather than keep arguing about what the past means.
Okay, one thing I want to do here is Anthony, up in the corner there, he actually created a video and animated the original idea of what Oumuamua was. So here's that video clip. And he made this for you, Doctor.
Thank you.
Oh, sorry, Avi. Would that be the way that it was moving? Would it be tumbling in a different
It would
way?
also spin along the other axis as well. So tumbling is not just around one axis, and also it would not look like a cigar. As we discussed, it would be mostly flat. Now, whether it was razor thin or not, that's a separate matter. But if it was, for example, a sail or something like 2020 SO, then it should have very thin walls.
Right.
How could we prepare for the next interstellar object like this that comes in?
Oh, we don't need to prepare. All you do is just pay attention to the data coming from the large survey of space and time. It's called LSST of the Vera Rubin Observatory, and it will have many more Oumuamuas like objects. And because it would cover a bigger chunk of the sky for a longer time and with better quality than pan-stars. So there is no doubt, unless Oumuamua was a one-time thing, that is possible, but it's very likely that we will find more.
You mentioned earlier, how you favor AI. Do you think that some of these UAP that are possibly interacting with our solar system, with Earth, could be extraterrestrial AI? And what do you think of people's accounts that maybe there are also piloted UAP from, again, this is history. There's a lot of data out there.
I mean, ideas from the past are very useful in terms of guiding us, but we should we should carve new territory of knowledge based on data. That's all I was saying before. But in fact, ideas from the past, or ideas even from science fiction, should be just inspiring. That's no problem. But it will not represent scientific knowledge, of course, until we find the data. So what I was imagining are two types of visitors. Okay, you can imagine space trash, which are basically devices that are not functional anymore. Just think about Voyager 1, Voyager 2, New Horizons, Pioneer 10, Pioneer 11 that we launched to interstellar space. Within 1 billion years, they will not be functional. They will be just trash in space. So you can have objects like that. They would tumble, they would collide with Earth, they would not maneuver, okay? And it may be that these are the most common objects, but you can also imagine what is claimed to be extraterrestrial UAP, like objects that are functional, that are able to maneuver. And for those, I would argue it's very likely that they have artificial intelligence, not biological creatures riding them. Because the journey through interstellar space takes so much time that biological systems will not survive. And it makes much more sense to use artificial intelligence. So for us to figure them out, you might ask, okay, what do we do if we find a visitor in our backyard? And we've never had such an experience. When people talked about detecting radio signals from far away, you have plenty of time to think what to do in response. But if there is a visitor in your backyard, you have to decide immediately what to do about it. And I say that it makes no sense to establish committees. Committees that will write a book of instructions, what to do if you see this type of object, what to do if you see that type. Because whatever they think about, these committees would represent their imagination. And our imagination is quite limited to what we experienced so far. And for example, nobody would think of a cell phone 100 years ago. Nobody would think of artificial intelligence 100 years ago. There was a very famous philosopher, Martin Buber, who described the interaction of humans with the environment as interaction in between humans, I and you, and interactions with objects, I and it. But if he would have known about artificial intelligence, then there would be another category, I and AI, and that's a completely different set of interactions than with an object. Because ChatGPT, for example, behaves very different than objects from 100 years ago. So Buber did not think about AI because he lived at a different time. And perhaps we are not thinking about technologies of the future right now. So it makes no sense to have committees decide what to do in this or that instance. What makes sense is that once we identify a visitor, we should monitor what it's doing. What kind of information is it seeking? And then decide how to respond to it. We should not engage before we know what it's trying to do. And I actually had a conversation about that with Henry Kissinger over Zoom a year and a half ago. And I asked him the same question because I wanted to know, based on his experience in negotiations with the Chinese and other countries that have a foreign culture to ours, what does he advise? And he recommended exactly that, to first listen to the other side before doing anything.
One thing I gotta say real quick, Darcy, Avi, I think actually that's maybe why a lot of people refer to the idea that we're not looking at the subject of UAPs correctly, because we're looking at it from a human standpoint with human sets of structure. And if we look at it that way, then conventionally speaking, we may be in error.
True. Yeah, that's true. That's definitely true. All I was saying before is, I mean, we should be completely open-minded about what we see, but we should rely on evidence. That's what I was saying. So if your evidence, if your data is incomplete, if it's not conclusive, you should not jump into the assertion that we are seeing, for example, new physics. First, you should do your homework, okay? First, you should collect good enough data that is beyond any reasonable doubt that demonstrates that existing physics is not applying to the object that you see. I have no problem accepting, that the idea that we are missing something really fundamental. But in order to convince ourselves of that, we really need to have good data and high level of confidence and high quality imaging or videos. And we haven't had that. All the videos appear blurry, the ones that were declassified from the government. From private citizens, you either get the eyewitness testimonies or cell phone camera images. You don't know what the camera was doing when it was taking this. So a million cell phone images are not worth a single video from a high quality camera, scientific grade camera, with very high resolution, that you have full control over, that you calibrated. This is worth more than a million cell phones, just because you know what the camera was doing and you know how it performs, the circumstances under which the images were taken. If you have a camera in a jittery cockpit of a fighter jet, you don't know what's going on around you.
Right.
Well,
if we could just find one picture, one image with a high
quality, yeah,
high quality sensor.
You remember this testimony in Congress during the discussion about the report, and there was a very an image that was not really convincing that was put on display. And so it's really unfortunate. I mean, you can say the government cannot release classified data for the reasons I mentioned. What we have at our hands publicly is not of good enough quality at the moment.
Right.
I would argue just one thing with you, Avi. You did mention sort of the video that came from fighter aircraft, right? And I spoke to Seth Shostak about this. His stance is, it's, could be some kind of anomaly in the camera, yada, yada, yada. The only thing that doesn't really make sense with that argument is that these fighter aircraft are set up with state-of-the-art gun cameras. So this technology is filming in a light spectrum that the human eye can't even see properly. So that's how they pick them up to begin with, when they see them as like a little tiny, in the USS Nimitz footage, it's a minuscule object down by the surface of the ocean. And then, if you listen to the testimony from multiple pilots that were tracking the Tic Tac UFO, it flew from down near the ocean up to their, altitude, and it ping-ponged around the sky near them. And when they observed that with their eyes, and they also recorded that small piece of footage in FLIR, far light infrared light spectrum camera technology, then I think that footage is credible, and that it's better than a cell phone for sure. I think the cell phone camera is not even capable to record or capture objects in that light spectrum. So I don't really think it's a fair analogy.
I mean, the point of the matter is that this data that you are referring to is not, the high quality data is not available to us, and whatever is available is not conclusive. So you have to combine it with eyewitness testimonies. But just imagine asking a cat, looking at a laser spot, that is moving around very fast. The cat would say, look, this is crazy. What's going on here? This object is moving back and forth and doesn't have any wheels to propel it, but it's not actually an object. It's a spot of a laser. And so the point is, these people saw something, the cameras recorded something. We don't know what that was. And even if it was an object, it could have been an object manufactured by other sections of government that didn't want it to be known. I mean, so my point is, just relying on an historic event for which we have incomplete data is not a good way to proceed, okay? You can believe or not believe. That's a choice you can make, just like biblical stories of miracles. You can believe them or not believe them. But if you want to progress in terms of your scientific knowledge about reality, the reality that we all share, the question is, are there objects from extraterrestrial civilizations near Earth? You just want to know the answer to that. You don't care about what people said on one occasion or another, what they saw, you want to know the answer to this simple question. Are there objects manufactured by an extraterrestrial civilization near Earth? It's a very simple question. It's a question that a plumber would understand. Anyone would understand. We're talking about objects manufactured by another civilization like us, technological. That's it. Objects. Okay, so how do we know if there are objects? It's really a simple question. It has nothing to do with the military, has nothing to do with the US government, has nothing to do with eyewitnesses. It has to do with whether objects are out there. So the way to find out is to use the best instruments we have to record them. And why would we argue about what people reported 20 years ago with incomplete information, and whether that was an infrared part of the spectrum, or whether these were real objects or spots of beams or whatever? Talking about the past has the disadvantage that you can't really test it. You cannot go back and check it. But on the other hand, if you are monitoring the sky now, you can do a better job. So instead of arguing forever on social media, the way most people do, arguing and asking the government to declassify again and again and again, instead of doing that, wasting our time, why don't we just focus on getting better data? If there are objects out there, we'll see them.
How is your data going to pick up these objects and present it with as much clarity in perspective?
Because we are from every observatory, we are monitoring the entire sky all the time, 24/7, the entire sky, in the infrared, in the visual band, with a passive radar, and with audio sensor. So in other words, we are listening also. So we are having a full movie of the sky. And then we use artificial intelligence to analyze all the objects that are. So on the one hand, you might have some images of objects, but on the other hand, you will see how they move. And in both ways, they might look peculiar. If they move in ways that our technologies are unable to reproduce, and we can tell that they are technological in origin, that would be extremely intriguing. And then we can get even more data, if we find something like that. Because if they're out there, they're out there. So we should see them. I just don't understand why we keep obsessing with the past. Let's just look and see if there is anything out there.
Right. I actually do that. I actually go out every night and observe the night sky. So I'm looking for anomalous movement, anomalous objects.
Yeah.
And last summer I actually came across a few.
Yeah. So the key is to get good data that it will be convincing beyond a reasonable doubt. And I don't care who the messenger is, by the way. I don't care if it's the US government, if it's private citizens. I just want to get the data that will convince all of us. Okay. And if others are not doing it, the Galileo Project will do it.
Good.
Perfectly
Empirical data.
Mazel tov.
Thank you for starting that on your own. I understand that you originally approached Bill Nelson from NASA and that he didn't even respond. So you went out and did it on your own. Kudos on that.
Bravo.
Yes. Anthony, any last comment?
No, I just want to thank Avi for taking the time out with us today. It was an absolute honor, a privilege, and a pleasure. And I wish you nothing but continued success on your endeavors.
Thank you. And stay tuned. We will report whatever we find.
Thank you for coming. Yeah. And thanks for your patience with us scientific laymen's.
Not at all.
Yes.
I mean, I didn't know much science when I started. It's all a learning experience, and hopefully we learn something new on this endeavor.
Yes, and thank you to Avi for answering my email and coming on the channel. I've been wanting to have you on for quite some time. You're an inspiration to me, so keep up the good work.
Thank you. We'll do. We will try not to disappoint you.
Okay. We want to thank everybody who participated in the chat room and everybody who watched online. And from all of us on the panel, have a good rest of your afternoon, and we'll see you next week.